Hello everyone. We are Memories.ai and I'm Ben. I'm co-founder and CTO of Memories.ai. I'll start with introducing our company and team member of our company and how we start with Memories.ai. So Memories.ai is an AI company dedicated to reshaping the machine perception, like how it can remember things. And our team members, the founder is Sean. He was a PhD at Cambridge and then went to University of Bristol as a professor. And I was previously working at Meta, especially working on two products. One is the Ribbon Meta, the AI glasses. I was the lead on the on-device perception models. And also I was part of Llama Vision, Vision development. And also our chief AI officer, Eddie, is a Gen AI, chief scientist in Gen AI on the Supreme Management Lab. So how do we start with Memories.ai? So I met Sean like 3 years ago when we were working corporate rhythm and algorithms. And we think that when LM solving problems, it's basically focusing on the current context without having much knowledge about like the past memories. So we think about like when you're solving a real problem, like past memories is very important. So like that's why we have this idea and we started to build Memories.ai by last year. And currently we're like some company of around like 15 people. Yeah, so I would really introduce like how we build like visual memory, and like what does visual memory mean in order to build that. So like visual memory like mainly comes from like videos. So like why it's important for human to have visual memory for AI to have visual memory. So if I ask you a question, what did you eat yesterday? Like you not only like remember a few names of the food or like the name of the restaurant, but you also vividly recall a few images or snippets of what you ate yesterday. So that means like inside the memories, you not only summarize things into text and remember that, but you also like save some images, videotape snippets into your memory, and when I ask you something, you will recall those visual stuff. So that's why it's important to have visual memory. The videos are very heavy, like takes a lot of bandwidth, like even like LLMs, LVMs, the deal with videos takes a long time, especially as the duration is long, the complexity is squared. So we have a compression layer that when the video first coming, it decides like what's important in that video. What's important in the temporal information, like continuous bridge connections. And those are important. I imagine it's similar to like H264, like it's compresses videos into K frames. So we detect the key semantic information inside the videos, along both spatial and visual, both spatial and temporal information into in our own representations. First, so we compress that compressed information, and next one is the text layer. So we're preparing a multimodal to index different modalities into a line single data space. And then within those data space, information has been as vectors and values, so that later on, when you have a question, like we want to search, you just can directly use the feedback. But when you want to ask a question and for an answer, we have a paired decoding model to decode information from those values and generate do text generation. And then the next one is aggregation layer. So if you remember things in visual, it's not a single one. Like you don't just remember like single information from a single video and remember another information into another video. You have to connect those information between videos in order to form your aggregated map. Like your experience, or insights, summarizations. So we have an aggregation layer that merge embeddings, merge information from embeddings, then form embeddings, and from different hierarchical embeddings. That's the memory layer. That's the aggregation layer. And also, if there's any metadata, it's any structured data, we'll also build a non-structured content. But the most important thing, how you merge embeddings, how you merge information from embeddings. Yeah, so that's aggregation. On the most top of it, that's the starting layer, where we have our API, so you can search, you can retrieve, you can do decoding of embeddings for text generation. Yeah. Yeah, and as like why AI or why agents need visual management. So nowadays people not only post with blogs, like not only post with text, they also post with videos like TikTok, Instagram Reels, the TikToks. There are like around billions of videos posted every week. Like even on TikTok, that's 80 million videos posted every day globally. So if there's no efficient system to compress to index information from those videos, the AI agent cannot efficiently process those information and utilize information when solving problems, when answering questions. So we are building this Smart AI, both infrastructure and the model to do that, to help AI agents that to enable it to process large amounts of video information from both network all over the internet and also from personal media. Yeah. So in terms of like the as I said, videos are heavy. You don't want to like submit and transfer videos every day over the internet. There's a lot of bandwidth, lot of network fee. So what we are doing is that for some of our embedding models, it's not enough and we should to be deployed on edge. So we are specifically working on optimizing our model on certain edge chips because most of like current day smart wearables, mobile phones, which are like main input sensors for videos, they are like supported by like Qualcomm Snapdragon chips or AI-driven chips. So while optimizing our models on their NPUs and CPUs in order to be deployable on the device. So the pre-processing, the compression, and the indexing can all happen on device. That's one thing that we're recently doing, and that's we also launched our Cofounder cooperation with Qualcomm last few weeks ago. Yeah. So all the goal is to make the inferencing with low latency, low power, efficient enough to run on local device. So you don't have to transfer the whole video, the whole raw data into the cloud and waiting for response. Everything is processed locally, and you just need to transfer some of the like up data from the model, and it's more safe. It's more it's like protects more about your privacy, and it's requires less bandwidth. Yeah. Yeah, so one of our just showcase like that we will build a demo app on Samsung. That's a POC we did this year with Samsung, and they invited like 6 companies to do POC every year with them, so that we built our like whole system onto Samsung Snapdragon, Samsung S25 Ultra, and it's an app where you can just search and chat with your own personal AI algorithm. And we compare to Google, Apple, and Samsung. Like Google and Samsung, their own gallery requires you to upload your images to their cloud and deal with it, and then all the information are from the cloud. But we can do it. We can do everything locally. So that's one of the milestone that we did this year. Yeah. So about use cases. So the first one is our multi-modal album. So that's also like what we're partnering with Samsung to achieve this year. And everyone has a lot of images and videos on your phone. You want to make your album more like intelligent. You want to search from the album. We don't just want to search for like certain keywords or tags. Like I want to search a dog, search for car. Instead, you want to search for like having beer with my friends on Friday nights. Those kind of things are like important for the memory, your personal memory. Those are important things. But semantic search is not done on like local device. So we do that with Samsung, Oppo, Vivo, and most mobile like Android mobile companies to achieve that. That's the first use case. Yeah. And second one is smart wearables, like Ribbon Meta, like Rocket, like Rabbit. Those are like always on or like all day wear smart wearables. They keeps include like lots of contacts every day. So some of them has camera always on, some of them has audio always on. So they definitely want an efficient way to absorb or intake those contacts when they receive it. And that's also like another thing that will help them to enable that every seconds of video, every seconds of audio we receive on the device could be processed, could be efficiently processed, in order to make them into memory and then provide context for later, like problem solving, QA or search. Yeah. So that's for smart wearables. And also like for surveillance cameras. So this is not like security camera for like factories or like for commercial use case. This is also security camera for like single family houses, like for home use cases. So one problem that we find that in single family house security camera is that one thing is that there's a lot of false alarms because it only use currently it's only used like CM kind of architecture to detect what's inside the video of the camera. Like if a person appears, it generates events. If there's a car moving, it generates events. But it doesn't know like who the person is, like whether the car is the car from your house, it's all like a car just on the street. So those are the important things that the users want to know about, know from their camera at home, not just like single event detection or human detection. We want to detect if that human if that person is one of your family or is in your friends or is he just a working employee in the community. So those are important, but those have to be done through memory. Because facial recognition that is not always useful on those cameras. You cannot always capture a very clear face on the camera, but like how human recognize if a person appears in the camera is a friend or is not a friend. You not recognize not only from the face, but also how he walk, the pattern, the clothes he wears. So like the phone memories of that person, that's how you recognize if that person is a friend. So that's how we do it from like visual memory. So we don't do like facial recognition. Like facial recognition helps, but like more than 50% of the time you cannot capture very clear face. So we recognize like the human identification from the pattern of this person, and the pattern is coming from the past visual memory. Yeah, so we launched our Memories.ai in July, by end of July, and since then, we grew very fast, and it's mostly like on the enterprise side. On customer side, we have like 20 users live every day, and on the customer side, we sign over like 60 companies within like 3 months, and most of them are like either mobile phone companies like Samsung, Vivo, Oppo, or like security camera companies like also usually Wise, those are popular ones, and also the others are like multi-modal agent companies. Their agent has to intake information from different modalities, and the heaviest one is from the video. So we're enabling them with our API to deal with video information. I think yeah, basically that's all. Yeah, and also we launched collaboration with Qualcomm 2 weeks ago, and I think by next year we'll deploy our SDK and our model onto the newest chip, Snapdragon 8 series, and also their next series for smartphones. Thank you. Yeah, please.
Technical questions about your video architecture.
Uh,
So when you go from long videos or even reels like videos to embeddings, what is the size of a typical video fragment that is being converted into a single embedding, and how wide are the
Okay, so in terms of like how we deal with long videos, definitely we don't turn like a 1 hour video into a single embedding. That's not impossible. Like a single embedding was a even dimension of like 4096 cannot capture enough information for a long video. But often you don't have to like you don't have like by capturing information from a long like a 1 hour long video, we have a segmentation model that segment not only like from the pixel level, but also from the temporal level. So it's either event detection, action detection, or like camera change. So that's our important thing where you can segment a long video into different small segments, and you generate events for each of one of them. But also like how do you have an overview of the whole video? That's by aggregation. So you merge events, you merge information from embeddings into new things, into new events. And that works also like for a list of small videos, and you can also aggregate them. So it's a general way to deal with both long videos and large amounts of videos. And in terms of like the size we generated for each video on our website, because right now I think we have over like 5 million videos on our, like people upload like more than that to our website. So on average we generate around 1% like in terms of size of data, like 1% of the original data. So for example, if you upload a 1 gigabyte of video to our website, then the process data and values the data generated from this video will cost you like 10 megabytes to save. Yeah. Yes, please.
think if I understand correctly, when you have embeddings and you change the model that calculates with embeddings, you have to recalculate to recreate embeddings.
Yeah.
So are you trying to keep them backward compatible or column? Because otherwise you have to recalculate them again.
Yeah, so for search, definitely you have different encoder or different modalities and make sure they align in the same layer space. That's one thing you have to do. And for like decoders, like decode embeddings and to generate the text. So we co-train this decoder with our embedding model so that they are trained together. So that's why we can decode embeddings into generating